Welcome to Rges, Algebra 2, Lesson 25A, and we'll start with a review. You will be having a test on Wednesday on chapters 6 and 7. We've already done a good review on chapter 7, but I put down one of each kind of problems I'm expecting you to know in chapter 6. This will be solving simultaneous equations by linear combination. Go ahead and do the problem, then check yourself with the answers on the right by substitution. I think most of you are very strong with that already. If a constant is in the denominator, as in number 3, where we have x over 3 plus 4y over 6, I'd go ahead and change that first equation by multiplying everything through by the common denominator 6, so you get rid of the fractions. In the second equation, multiply everything through by the combination or by the common denominator of 10. So you'd multiply by 10, and all your factors will, all your fractions will drop out, and then you'll have something more similar to 1 or 2. Now in number 4, we have variables rather than constants in the denominator, and that's where you use the u and v technique. Let u equals 1 over x, and so that equation would, and v equals 1 over y, so that equation would look like 5u plus 6v equals 38. Recall that? Solving for u and v, and then solving for x and y. Last thing I would want you to know from chapter 6 is the literal equations. Go ahead and study a few of those. I will have one of those on the exam. The sixth section or type would be where you have 3 equations, three variables, x, y, and z, and I'm not going to put one of those on the test. But go ahead and study all of these as well as chapter 7, which we've already reviewed well. Now let's go ahead and look at 8.1, which will be the focus for this section. So the main idea with 8.1, and we did give you a little bit of a preview last time, but we want to recall that anything to the 0 power equals 1. Anything to the first power equals whatever we began with. So 7 to the first power is 7, and x to the first power is x. Anything to a negative power is the same as putting it in the denominator. And if we had 1 over x to the minus a, that would be the same as x to the a. So it goes in both directions. And the other one, the new idea, is if we have a fraction like 7 to the 3/5, this is the exponent, and this, or a power, I should say, power, and this is the root. In other words, this can be translated, this or simplified, to 7 to the 3rd power and then take the 5th root, or the 5th root. So we're always taking the denominator part as the root. We're always taking the numerator as the power, but we could do it in either order. Okay. And so you choose the order that makes the numbers work out most efficiently. So if you remember to the 0 power, you remember whether you're going to take it to the denominator or not because of a negative exponent. So let me go ahead and do several more of these kinds of examples. So let's take a look at these. Anything to the 0 power is 1. So this is 1. This is 1. This is 1. Okay? Don't make it more complicated than that. Anything to the 0 power is 1. Now this is to the negative 2 power. The fact that it's to a negative power means drop it into the denominator. This is the same as 1 over 4 times 3 squared. 3 squared is 9, so this would be the same as 1 over 36. Okay. In the next section, it says write with negative exponents and no denominator. So again, I'm going through several of these because students often have trouble with them, but you just don't want to make this too complicated. If we're dividing by something, this is in the denominator, but I want to move it to the numerator with a negative exponent. So this becomes 5 to the negative 1. This is the denominator, so it becomes 2 to the negative n. This is, the m is already in the numerator. These are in the denominator, so this becomes b to the negative 1, n to the negative 2. Hope this is clear to you. These two are already in the numerator. These become, want to pull up to the numerator. They're in the denominator right now, so this becomes c squared d, a to the negative 2, b to the negative 3. Now, it's probably more proper to go ahead and do these all in alphabetical order, so really I would have written this a to the negative 2, b to the negative 3, c squared d. Okay. Of course, if you have the c, for instance, variable more than one time, you would want to combine them by adding, right? So this is what's in the denominator right now, so that's the part we're going to change. We'll have a to the m. Putting it in a better order here, we'll go b to the negative n, and then c to the x. All right. And that's how that works with positive exponents. Again, we're just doing it the other way. Let's look at just a couple more here. 2a, x to the negative 1. We want to convert this one to a positive exponent by putting it in the denominator. Just like that. Okay, I think that you could do the rest of those. Let's say writing without a denominator. Let's look at something like 30. It says a squared m cubed over b cubed n squared. We don't want a denominator, so these two have to be changed. And this is a squared b to the negative 3, m cubed, n to the negative 2. So we're just taking the ones from the denominator up and changing the exponent. If it's positive now, it'll be negative. If it's negative now, it'll be positive. And that's simply how we do them all. Okay, now when we get down to something like 40, and this would be 16 to the 3/4. Okay. Can I take the fourth root? If I can, this is the root. So if I can take the fourth root, go ahead and do that first and then raise to the power. So that would be 2, because 2 times 2 is 4, times 2 is 8, times 2 is 16. So this would be 2 to the third power, and that is 8, just like that. Okay, so I would also like to talk to you. I'm going to let you do the rest on your own. We can talk about anything else you have trouble with. I'd like to also go to your word problems on page 163. And I'd like to talk that through with you. Word problems, page 163. So these word problems have to do with rates and a job. Okay, rates and a job. Or in a job. Now, probably the trickiest part about this is to recognize that the entire job will be represented by the number 1. And each part of the job, the one person's doing a portion of the job and another person's doing another portion of the job. So the entire job equals 1. So we are going to care about the number of hours each person works, and we're going to care about the rate, how much of the job they get done per hour. Okay. So it says Emily and Mitchell can clean their grandfather's RV camper in 2 hours working together. And if Emily cleans for 1 hour alone, Mitchell can finish the job in 4 hours. How long would it take for Emily and Mitchell each to clean the RV working separately? So, now notice this rate is not the same as when we think of rate per hour, when we think of how much a person is making, like $7 per hour. What we're saying is this is the amount of work, the amount of the job she's able to do in each hour. In other words, if Emily takes 7 hours working on her own to do the job, then she is doing 1/7 of the job each hour. So this is a critical chart to recognize and understand here for these kinds of problems. So study that and think about it. If it takes me 5 hours to do the whole job, then I am doing 1/5 of the job every hour. That's the key right there to these kinds of problems. That's my little key symbol. All right? So then let's take the information. Now that we've got that as our basis, let's take the information. Emily and Mitchell can clean their grandfather's camper in 2 hours working together. So Emily is working for 2 hours, and her rate per hour, how much she gets done per hour, is that. And Mitchell is also working for 2 hours, and he gets this much of the job done and I'm taking that right off that chart, every 2 hours, in 2 hours. So altogether, they finish the job. And that's the other key, putting that 1 in there. Now, that's one scenario. What's the other scenario? If Emily cleans for 1 hour, so she would be 1 times 1 over x, her number of hours times her rate per hour, as far as how much of the job she gets done, then Mitchell can finish it in 4 hours. So he's going to work 4 hours, and of course his rate, how much of the job he gets done, is 1 over y, and then they'll finish the job. So how will I solve that? So those are my equations. You're halfway there. Now recall that if it's 1 over x and 1 over y, we're going to use the UV, the UV technique. So this will be converted to 2u plus 2v equals 1, and 1u plus 4v equals 1. So we'll go ahead and multiply this by 2. You've got your choices. This becomes 2u plus 2v equals 1. This becomes 2, let's do it by minus 2u minus 8v equals minus 2, adding straight down. We'll get 2 minus 8 is negative 6v. 1 minus 2 is negative 1, and v equals 1/6. So that's how you would solve that, and that simply means x, that Emily would work 3 hours and Mitchell would work 6 hours, okay, if they were working separately. Now let's try to go ahead, and I'm going to just give you the equation for number 26, and then I'll expect you to be able to work the rest of these on your own. 26 says, Mr. Tanksley, the school's speech teacher, and Mr. Franklin, the school's art teacher, can build the set for the school play in 6 days. If Mr. Tanksley works 2 days alone, Mr. Franklin can finish the job in 8 2/3 days. How long would it take each to build separately? So we got Mr. Tanksley and Mr. Franklin. Go ahead and make your chart. Now notice all these charts will fundamentally look the same. I like to go T's and F's so I remember who I'm talking about as opposed to X and Y's, but you certainly don't have to. Now for the next, so the chart is basically always thinking the same way. Now, how would I come up with my equation? It says if they build the set together in 6 days, okay, so Mr. Tanksley is working 6 days and his rate is 1 over T. And Mr. Franklin is working 6 days, and his rate is 1 over F. And altogether they do what? the whole job. Okay, don't forget that, always 1. Mr. Tanksley works 2 days alone, 1 over t. And Mr. Franklin can finish the job in 8 2/3. Let's go ahead and convert that. 8 2/3 is the same as 26/3 of a day, and this is his rate. And when they're done, they finish the whole job. Converting to U's and V's, you'll go ahead and solve that on your own and see what you can do with that and the other two. Okay. The last thing we want to do is give you a preview of 8.2. Now things get to looking more complicated, but they're really not. The trick is to remember the rule. When we multiply, what do we do to exponents? When we're multiplying variables with exponents, we add exponents. Okay. So if I had number 2, it said a squared times a to the 0. Well, what is a to the 0? Anything to the 0 is 1. So that simply is a squared. Let me put a few more down. This could look very complicated, but if I remember and I'm matching up my variables and adding my exponents. 2/5 plus 3 more fifths is 5/5, so this would be m to the 1 or simply m. N is the same as n to the 1, adding my exponents to the 1, and 1 minus 1 is 0. What is n to the 0? N to the 0 is 1. So this is simply m times 1 or m. Let's look at another one. Don't get panicky. These are the same variable. We're just going to add exponents. We only have one m, so that'll stay there. We have a minus n plus an n. Those will cancel out, and we get a minus p. See how that works? Okay. Now, in the next grouping, what we have is FOIL, or actually in 13 and 14, we're going to have to expand more. We're going to take the first term, distribute it through the 3, the second term, distribute it through the 3, the third term, distribute it through the 3. But the others, let's look at FOIL. So I think you'll be able to figure those out. You just have to realize it's a longer problem. Let's just look at 10. It says x, I'm having a hard time reading these, to the 2/3 plus y to the 2/3 binomial times another binomial, x to the 2/3 minus y to the 2/3. Okay. So first terms, we're going to add those, and that's going to be x to the 4/3. The outer and inner will have x to the 2/3, y to the 2/3, minus x to the 2/3, y to the 2/3. So they will drop out, just as you would expect when you have the addition and subtraction of the same binomials. Okay. And then, so all you're left with is the last term, y to the 2/3 minus, or times, well, negative y to the 2/3, so that'll be minus, and this will be y to the 4/3. We're adding exponents, right? Okay. To divide and express without denominators, let's go ahead and do a couple. Recall, n to the 0 is simply 1, so this will be n squared. On the next one, we're going to subtract when we're dividing. So we're saying r to the 3/2 minus a negative. So 3/2 plus 5/2 is 8/2, or 4. Just like that. Just think your rules through very carefully. If we're raising to a power, we are multiplying. So let's look at something like 24. Again, just a good review. I'll look at 2 over here in this section. Okay, we're going to multiply when we raise to a power. So 2 times 1/2 is 2/2 or 1. Right? And so this will be A. We're multiplying, but the directions say leave the exponents positive. So I could do this in 2 steps. This is simply a to the -8, but now I need to convert this to a positive, which I would do by taking it to the denominator. 1 over a to the 8th. Okay, I think you can follow those pretty well. If we have any confusion, we can talk about it in class. I'd like to see what you can do on your own with the rest of these. I think that's a good review. By the way, you are going to factor, okay? So think that through. That'll be a good exercise for you, and we can talk if you get confused there. All right, I think that's the end of this lesson for today. You have a wonderful day.